Hello everyone, welcome to class 1 of machine learning, which is all about automatically learning a highly accurate predictive or classifier model or finding unknown patterns in data. So here when we talk about machine learning, mostly supervised and non-supervised learning, they're divided into two parts. We have another one, I'm not bringing that here, reinforcement learning. But coming to the main one, unsupervised and supervised learning. Here in supervised, you will come across two kinds, classification and regression, and unsupervised learning, clustering. If you are from statistics or actual science background, you must be knowing about regression. The other two will be doing here. I'm not bringing any Python or R programming for today's class. First, we have to understand the statistics behind all this. So when it comes to traditional programming, we give data and program, and finally we get output. In traditional programming, you give data and you give program, you get output. You see the difference here. In machine learning, we give data and output, we get a program. That is the difference. See, data, answer. If x is 1, y should be 2. This is output, this is input. If x is 2, y is 4. So you have to find the program, you have to find the model. Program means what? Model. So seeing this input and your output is also given here. See, data output. You have to find the model. Program means model here. Here data models are given, you have to find the output. So data output given. If data is 1 and the output is 2, if the data is 2, output is 4. So data output you have to find a formula that is called model program. You have to find a formula which will describe this data and output. So in machine learning, you have to find a model somehow which will classify. In classification problem, in regression model, it will be regression. Okay. So we'll go through one by one. You have to give label data. Label data, when I say, these are rectangles, you say to the machine that these are the rectangles and these are triangles and these are whatever structure. Okay. Polygon you can say, or you can count 1 2 3 4 5 6 hexagon, and then you have to train. We'll go to exactly what is training later. I will tell you that what is meaning training here. So you have to train the model, and the labels I said written here already. The labels, this is labeling. Whatever data you give, you have to say something about each point, data point. Here the data are the triangle, square and hexagon. Now you train. Okay, after training, you give new data in the form of a square or triangle. If you supply new data, the machine has to say this is a square and this is a triangle. Because these are already labeled, machine will be able to say. Now my question here, the first and foremost question, it's very, very important, very simple question, but very important. We can train the baby showing different pictures, and then finally when we ask this kind of a structure, then he or she will be able to respond, answer, right? This one looks like this, and this is label data, this is square. So he or she will be able to say this is a square. So we use our eyes, vision. We have vision. Okay. So using our eye power, we can see the pictures and it will go to our brain and it will be processed through our neuron. Then we'll be able to answer the humans. How about a machine? Machine has no eyes. So how you train the machine so that machine will be able to know? Now, how a machine without eyes can decide between a square and a triangle, or maybe a square and a hexagon? Okay, if you show only one, this one, suppose machine has to say this is a square. If you show this one, machine has to say it's a triangle. And it's not that all the time machine will show whatever we expect. Sometimes it will make mistakes also. And there where we find the accuracy score in machine learning. Because we are training, if certain things will look similar, you might get different answer. Now, you agreed, Anu? Tell me, how a machine without eyes will be able to say this is a square, this is a triangle?
Sir, it's not seeing the image. We are just inputting the data. So, on the
No, no,
basis of
okay.
the
Okay,
data,
how through Python programming language you completed, how can you
sir,
input?
image recognition, sir.
No, you are going to neural network. That is high level. Okay. Neural network, and neural network, we send the full image. And we talk about computer vision and whole lot of things. Okay. That will come after completion of data science 360. That comes in data science 360 plus. So if you send the whole square, okay, how can you send whole square in form of
Sir,
pixels
it
and all that?
trains according to the features of the square, sir.
Yes, this is the correct answer I wanted to get from you. Now, what will happen is, in machine learning, will not send the whole square, because to send the whole square, you have to divide into pixels, and pixel by pixel you have to send. First of all, you have to keep the pixels in something that is numpy. In numpy, you have to save the small pixels, and that data you have to send. Okay, but now we can send all this. When we started, even in machine learning, when we say supervised unsupervised learning, I'll show you here. I didn't write neural networks. The four things important here in machine learning: classification and regression when we say supervised learning, when we say unsupervised learning, clustering. These are the three mainly you need to know first. Then you go to the advanced level, where you will come across artificial neural network. That is where we use deep learning. I'm not going to deep learning. We are in machine learning.
Sir, will we get to understand the difference between supervised learning and unsupervised
Yeah,
learning
yeah, yeah.
later?
In today's class only.
Okay, later. Okay.
Yeah, yeah.
Okay.
That's a part of today's class.
Okay.
Now we know that we have to come up with a rule called program here, and data and output both will be given. We'll check here how data and output are given. So here data is given, and we know that these are square, rectangle. This is output. Output means output, we know either it will be a square or triangle or hexagon. So you have to say something. So what will happen is, we'll send the data through a programming language like Python and R programming language, and then it will check. Suppose you can say like this, you can make a column and you can write number of sides. This is where you can differentiate. This is the best thing here, I suppose. Number of sides. If there are 3 sides, you say it's a triangle. If there are 4, you say it's a square. If there are 6, you say it's a hexagon. It's so simple. However, it
So
will not. Yeah, yeah.
this diagram is from can we say that this diagram represents machine learning, or this is a traditional program? I believe it is a machine learning
Yeah,
because
this is machine learning. Yeah.
okay.
This is machine learning because we're training the machine showing data.
Yeah. So one is
And
data, this is output.
yeah,
In between
and
we are
output is in the form of a rule. The rule says, if there are 3 sides, you say it's a triangle. That's the rule. That's the program. So we are supplying data and we are supplying the output also. We are saying, see, output will be one among these. If you compare with the regression task I showed you, their output could be anything. I mean, that's continuous, but here it's discrete. So either the answer will be hexagon or square or triangle. So this is not a regression problem. This is a classification problem. We are classifying. There are three things and both are coming under supervised learning. So in classification task, you have to say one among them. So you have to say either it's a triangle or a square or a hexagon. That's all. So this is machine learning. Even we are doing machine learning only, not the traditional programming. Let's proceed further. Now, when I say it's a hexagon or a square or a triangle, how can you supply data? That is also something very important. I'm going to that now. Now, there are three types of flowers here. IRIS data set we say. And listen me carefully. In the data set, we'll take 50 of this kind, versicolor, and 50 of this kind, setosa, 50 of this kind, virginica. Three kinds we'll take in our data. And the number of rows will be 150, 50 of this type, and this type 50, this type 50. Now, if I see a lot of flowers like this, and someone says, you tell me, this is what? This is a classification problem. This is not a regression problem. In regression problem, we find a continuous one. Here we find a discrete one. So I'll be able to say, because I can recognize using my vision, my eye, I can see and I can say that, okay, this is versicolor, this is setosa, this is virginica. At least we can say, if you see the length and breadth, okay, this looks bigger as compared to this one. If you see the graph, you'll be able to know exactly. We'll go to the data set. So what we'll do is, this is called sepal, this is called petal. So in the data set, we measure this length and this width here. This is petal width, petal length, sepal width and sepal length. We have 50 of this kind. We'll take, I'll show you. See here, sepal length, sepal width, petal length, petal width for each flower. So suppose you've taken 5.1, 3.5, 1.4, 0.2 for each flower. So let's go to that. Now we have sepal and petal. Okay. So we'll see this length and this width, this length, this width. So four things we'll measure. So when Anu answered, that will take the features instead of taking the full flower, because it will be a lot of data. Again, how can you send the full flower through Python to the machine? That is something we'll learn. Okay, large data set will come and the way of handling will be totally different, and the concept of neural network will come. I'm not going to that. What we are doing is we're checking whether it's possible by taking some features. Here we consider four: length, breadth, sepal, petal, 2 for each one, 2, 2. So here 4, here 4, here 4. Like this, we'll take 50 flowers to train, 50 flowers here, 50 flowers here. So this is our whole data set. If you see the data set, the first 50, setosa, and you see these are smaller as compared to 5.1, 3.5, 4.9, 3, 1.4, 0.2. Now come to the next one. Versicolor. Here if you see 7, 3.2, 4.7, 1.4. There is some overlapping also. For that, if you draw a graph which can show you all the flowers, okay, that would be great. But anyway, we'll do that. That comes in visualization. We'll go to that later. Now, the second one is versicolor 50 once again. If you check left hand side, up to 100 it will go. Up to 100 here. And then comes Virginica, another 50. So 50 from each kind, we have considered 150 sample. The first one is the header, so it comes to 151. So 50 sample from Virginica. So the features we have to know. These are called features. We say independent variables in mathematics. So here we say feature. This is the dependent variable. We say here target. Remember, throughout machine learning, the target will be the dependent one and the features will be the independent one. This is a part of feature selection. Then comes feature engineering. We'll go to that. But feature selection means if you want to differentiate between two flowers, or if you want to say you want to predict, how can you predict? Not seeing the whole flower, because the machine, when I say the computer, when I say computer can see now, at least at this level, we say computer will not be able to see. So computer will see, take these 4 only. That means what will happen is, suppose here these are bigger, you can say smaller. They will go to the machine through what? Through the length and breadth, okay? Like 5, 3, whatever numbers we have inputted, okay? Through numbers only it will go. Now here length, breadth, here length, breadth, right? So what will happen is, suppose you have a setosa kind, but all others are small. Here it's big, okay? Then something, model will not be able to answer, because how we are training, that's important. We are training using only 4 features. So by chance in a setosa, if this one, if you consider this lip only and you see that, okay, these are bigger, whereas these are smaller, then computer will fail, because it can only take the features, okay? So using features will train, and then computer will be able to answer, or you can say the machine. Now let me go here. This is data. Now I use programming language Python, and then I will show you here. You need not worry about this. Now this is one app. This is Streamlight app. So what will happen is, I will not use any code here. I'll just show you. This is also easy. You will be able to do this kind of a app, web application. We say web app. So here sepal length, whatever I want, I can give, and sepal width, then petal length, then petal width. Then for all these values, I want my prediction. It says prediction probability 74% for 1. Again, the labels, the output labels you have to denote by 0, 1, 2. So when I get this one, if you see 74%, 1 is for versicolor. So it predicts versicolor, okay? This is what we have to do. So this is 100% statistics plus a bit of programming. So how this is coming, if you want to know this answer, for that you need to learn the statistical techniques. Here we say the supervised learning, unsupervised learning, whatever we have, around 12 to 15 you have to do. And most of the algorithms we can use to predict this using any programming language. Now we'll check one. Okay, suppose we'll use this 4.9, 3.1, 1.5, 0.1. It says setosa or not. 4.9, 3.1. Okay, 4.9, 3.1. Here 4.9, 3.1, 1.5. 1.5 exactly, it will be a bit difficult. Okay, let it be 1.49, then 0.1 it was, right? If I'm not wrong, it was 0.1, yeah. Now see the prediction. 0 is setosa, right? See 0. It predicted properly. And with 100% probability it's predicting. Now with 100% probability it's predicting 1. 1 means, sorry, with 1 probability it's predicting 0. The prediction probability is 1 for 0. 0 is setosa. Setosa written here. So setosa is 0. So we got setosa. See, these are the ones I supplied: 4.9, 3.1, 1.5, 0.1. This is correct. What you can do is, if you try with all 150, it might be able to give accurate result for most of the data I'm saying. Okay, we can try this one. See this type between these two, 6.3, 5.7. Okay, there are some overlapping. Later I will show through graph when things are overlapping. So you can try with this one also. It says versicolor or not, and what probability it says. When you say sample, it's 100%. I mean, it should be versicolor, but when you get probability, future probability, it will not be 1 all the time. Okay, we'll try with this one. 5.1, 2.5, 3, 1.1. This is 5.1, then 3.
Sir, 2.5.
This is 2.5. Oh,
Yes,
sorry,
sir.
half. I remember. Okay. Then the
3,
next, this 2.5. Okay, let it be. Then 3. Exactly 3, right?
yes, sir.
Okay. 3. Then next,
1.1.
1.1. Right. Okay, it's done now. Oh, here also 100% probability. Versicolor. You are correct. All the time you will not get 100%. Okay. Let me change randomly to something. See now. Yeah, now also 100%. Okay. So what will happen is, if you make something like this, then there might be a problem. Okay. Let me check now. Yeah, 46% chance, though this is the best one, but 46 with 46% chance, it's saying it's versicolor. Okay. Which one? One for versicolor. Okay. Yeah. So the probability, if you see for this one, it's 46%. I said you remember there is some overlapping. What will happen is, suppose the sepal length we say that is more, but when it comes to sepal width it's less. Okay, one of this kind, one of that kind, then obviously the chance is not that great. So you just compare training with a small baby 1 or 2 years. Similar way we're training here. The difference is the baby can see and using eyes and obviously brain, you can say baby can answer. But here whatever way will supply, whatever features, now we have supplied 4 features here, and you are able to see the answer. Now if you want to know here what application is it, this is a recent one. It's only 1 year this application came. Before that, people, the software people, they used to make web apps. That was not there. You had to learn after Python either Django framework or there are others as well. You can use R, all those, but these in R we have Siny. Okay, either you can use Django framework or you can use Siny. But now we have Streamlight. Even Flask is there for Python. We have Streamlight. Okay, it's a web application and it will give you like this, whatever way you write. This is again Python coded program. So you can write a Python program, whatever program you are learning now. Suppose it's 8 line, 4-5 lines extra you need to write for this app. That's all. You need not learn any framework. Okay, so it's very easy to learn. It will take only half an hour to 1 hour to learn this one, and then you can get this kind of a application. Otherwise, if you don't want this, you will get in Jupyter Notebook, and I will show you those things anyway using Python directly, and then we'll see this one. Now let's go back to our original discussion. So when we talk about prediction, here square and triangle, and the one I showed you, there also 3 things. Here also 3 things, but we showed, suppose a square, it showed a square. When we showed a triangle, it showed a triangle according to the diagram. If you show hexagon, it should show hexagon if you trained properly, and accuracy is 100%. But we will calculate the accuracy also, and we'll see, we'll discuss that, what is accuracy, how to calculate accuracy. It's very easy. We'll do that in another class. But yeah, in all machine learning classes, if you see, this time I've divided into four classes. First 3 classes will be without coding. Like this, we'll discuss the statistics, mathematics, everything. In the last class will be Python coded. Okay. Yeah, even I've decided to give you 1 or 2 classes a week for Python programming, those who have studied, who are studying now, so that you'll be able to revise things. Now, initially, there is a lot of problem. When students decide between supervised and unsupervised learning. I will show you a similar diagram. See, these are the 3 types of apples. And finally, you need to classify. This is a part of classification. Green, yellow, and red. I will show you a similar diagram. This also looks similar. This is unsupervised model, and the first one is supervised model. So what is supervised and what is unsupervised? If you go here, we're saying what is a green one. See the label, when we say label, labels are given here. Green, yellow, red. These are given here. And then you have to only classify. Suppose we'll show a new one. See, we've written training phase. In training, you train it. Then testing. You have to test it here. You test with this one. You ask, you show this one. Obviously, I mean, when I'm explaining, I'm saying you show it. You will not be able to show it to a machine or computer. Even when we talk about robotics, we always see a machine kind of a thing, or robot or cobot also, cobot. That means the machines they use in different companies. They do the automation work rather doing manually. These are cobots. So when we talk about robots, everywhere we see, when we talk about machine learning, we see a robot. Robotics is a different area. Even AI was not there in robotics. Artificial intelligence was not there in robotics some years before. Now also, I mean, if you see 80% of robotics, they don't use artificial intelligence, machine learning, deep learning, they're not using. Again, I will go to that later. When you show this apple, when I say, when you show this, whatever way you are showing, you have to give the features here when we talk about machine learning. In deep learning, you can send the image. Even for that also, I'll show you after some classes how deep learning works. But here try to understand when you show this apple, means how you show, you must know. With the features, then it must say it's a green apple. Now, the second one is when you show this one, it should say yellow apple. Okay. And the third one is red. So, label data. Data is labeled. Labeled means you know the labels here. Now, go to this one. Here, suppose a baby is playing. Okay. You give a lot of apples. And you say that, okay, you separate. Then you give another set. This is a different one. You train with this one, and for testing, suppose you're 100, you gave 10 now. You say whatever way we trained you, you have to separate those. So baby will be able to separate this. Now on a question, if you ask what is the difference, why you separated, what baby will answer?
So because the task is just to separate.
No, using names he or he has to answer, right? What
No,
he
we
will say?
didn't. No, we didn't ask the baby to say.
No, if you ask.
So that will be supervised learning.
No, I'm not saying that. In this case, forget about machine. If you train a baby with these apples, okay,
Okay.
how you train?
Sir, we just train on the basis of some features like sepal and
Okay. But you have not said that this is red apple, this is green apple. You didn't say anything, right?
Yes, sir.
Okay. So what will happen is when you show baby this 10, this is 100, suppose this 10 you show, and you say, okay, you classify. This is a part of classification. All the things are part of classification. I will start with classification. So I've considered only classification problem. Regression will do maybe after 10-15 classes when classification is over. So the task is to classify. C or he will be able to classify like this. But if you ask, no, what is this? He will not be able to say. She will say, see, they look different. So I thought this way I separated. That's all. There is no label here. She will not be able to say this is red apple. Even we never said here, like you said, we never said here that these are red apples. Even she doesn't know that these are apples. So what she will do is, in unsupervised learning, she will see the differences. Okay, they will look different. Using eyes, she can decide and she can separate. But if you go here you have to answer with the label. You have to say this is green. If you ask one prediction, okay, you say what is this? She has to say this is green apple, because you trained this way. You trained using apples and the labels. Now I'll take you to the other one. Here also you see the labels are there: square, triangle, hexagon. So you have to answer using these labels. Here there are no, sorry, here you don't have any label. That's why The answer will be only this way. This is also a binary classification. You have to say yes or no. What we are doing, this is so easy. Okay. Now, suppose a bank is deciding whether to issue loan or not. They will calculate salary. If it's greater than 60,000, first of all, less than 60,000, then you say no, you reject. If it's more than 60,000, then you check work experience. If work experience is greater than 2 years, then approve. If it's less than 2 years, normally the time 1 year, 6 months, 3 months, many they leave the jobs. So you are not sure. The company is not sure that the person will continue with the job or not. You say reject. Okay, this is a very simple binary kind of a classification. So what is the model, Anu, here? What is the model?
The decision tree.
Decision tree. Okay, decision tree. What is the exact one? We use CART, right? CART.
Yes, sir.
Yeah,
Classification.
classification. In classification, there are so many. Yeah, there are so many models. We will do one by one. So see the three flowers here: Setosa, versicolor, and virginica. So if you can make a 3D graph, how clearly you can see the separation. The second one you see here, this is a regression task, and we have three variables here. Given two variables, you want to predict the third variable. For that, we need a hyperplane. See, object detection. So now also there are so many models. In COVID days, people, they have made models using OpenCV. That's a deep neural network concept. Using that, you will be able to know the distance between people, and then you say whether they are maintaining the government order or not. Social distancing. Okay, you have to know the distance, then you say. So you identify the persons here in rectangles. Okay, this much for today's class. We'll continue with the machine learning algorithms in details from the next class. Thank you.